Hello, everyone. Good morning, good afternoon, good evening to all of you. So first thing first, let me quickly introduce myself. My name is Harshvardhan. I'm associated with the field of analytics and applied AI for almost 16 years now. I'm currently working as Senior Director for Global AI Engineering in Capgemini. I have rich experience in cloud computing, big data analytics, real-time event analytics, distributed and decentralized applications, various streams of enterprise AI and ML, be it classical predictive machine learning, cognitive AI such as computer vision, audio and speech analytics, knowledge graph, or NLP, NLU, NLG, which is natural language processing, understanding and generation, or MLOps. I deal with various AI and ML techniques in my projects, such as distributed machine learning, deep neural networks, MLOps, deep reinforcement learning, AI as a service. So far, I have led many successful AI and ML engagements in my career for various industries, such as banking and financial services, insurance, healthcare, retail, energy and utility, so to say. I'm also an author of a book on AI and ML subject area. The book is titled as UML of Deep Learning. I've also authored many papers which have been in the past published in ISC, in business analytics and intelligence conferences in the past. My passion is to share my know-how in order to evangelize and democratize new frontiers of the technology. So, well, that's my introduction. What I'll do that, okay, we will kick off with the topic of the hour, which is the rise of machine learning and AI in the IT industry. In fact, my whole intention is to distill my experience and then convey it to you throughout this session. Here is a quick rundown of what we are going to be discussing in this session, the agenda before you. So we're going to be talking about what is AI ML. You would really get to see that, okay, what's the background of artificial intelligence and machine learning, how exactly it's being theoretically defined, how exactly that AI and ML field is adopted by the industry. All this is what we will be talking through in what is AI and ML. Post that, we'll talk about AI and ML applications, which are primarily about how exactly the industry is also adopting the AI and ML applications, how exactly they're embracing that AI ML to really create a lot many smart applications to help their customer, to help their business, right? Then we will get on to the future scope of AI ML, which is pretty interesting in the sense that, okay, you would get a feel and a view that, how exactly the whole field of artificial intelligence analytics is shaping up over the time, right? And what's the kind of shape it is going to be attaining to. And with that, if you are already into the field of artificial intelligence or machine learning, you would really get a couple of clues that how to shape up your career, how to really kind of evolve your career in coming days. With that, we'll move on to the key skills of AI and ML specialist, which we will talk in detail about the kind of skills which you require it to get from the beginner to the practitioner to the specialist level. So that's what will be our focus. And then I believe that possibly that would be of great interest to you, of anybody who is either at the beginner stage to really kind of move to the next pedestal of their experience and maturity in the field of AI and ML. And with that, we will come to the final part of the agenda, which is how to get a job in AI and ML. And this, I believe, would particularly interest a lot of you here for very many reasons, that the way it has been structured, that it can really help not only the beginners, but also the experienced professionals. A beginner can really get a view that, okay, how can he or she can land to a good AI ML job, and an already experienced professional, we will talk through under this particular section that how can they really build, evolve, or further shape up their career in the field of artificial intelligence and can land to a better job, right? So that's like a quick agenda of what we are going to be talking about. So now let's get going on with each and every topic of the agenda. So first, let's dwell into what is AI and ML. So let's have a look at some of the milestones in AI research and development. Let's begin with 50s. as I said, artificial intelligence had begun in 1950s. What you're seeing on your screen is a chess computer program which was created by Alan Turing, who is also widely considered to be the father of AI. This particular game or algorithm was called TurboChamp, and back then, TurboChamp logic was based on just a few of the most basic rules of chess, and it was only able to think a couple of moves in advance. That's what 1950s Turbo Champ for you. And just a very interesting tidbit, a quick reminder. Fast forward to 1997, a Deep Blue. You must have heard about Deep Blue, a chess playing system developed by IBM, which could beat Gary Kasparov, who was then a world chess champion. But nevertheless, TurboChamp, the chess algorithm, which was written by the Alan Turing, and makes the mark of the beginning of evolution of AI, right? With that, then we'll move on to the 1960s. In fact, in 1960s, rather in late 1960s, computer scientists started working on machine vision learning, which is now called as computer vision, a specialized interdisciplinary division of AI, and leading university across the globe started developing machine learning in robots. One of such great initiative came from Waseda University, which is based out of the Tokyo in Japan. This university initiated WABO project. WABO stands for Waseda Robots, which was conceptualized as humanoid robo. Humanoid, which means human-like. So human-like robots, right? That's something which is marking the 1960s. In fact, Waseda University successfully developed WABO 1 project in early 1970s. You see it here, I'm moving my cursor, moved from 1960 to 1970s. And WABO 1 was the first full-scale, world-class, full-scale, general-purpose humanoid intelligent robo. It was the first humanoid which was able to walk, communicate to a certain extent. It can use its vision system to measure distances and directions to the object. It had capability to grip and transport object with hand, but it was a very general purpose humanoid. This is, I would say, the mark of the beginning of the humanoid, the holistic, the cognitive learning, what we call it now, the machine learning and all that, right? So that's WABO 1 for you, and that's 1970s. Now from 1970s, let's move to the 80s and see that, okay, what sort of advancements which have been done in the area of research in 80s. This, what you're looking at, is a continuation, right? The continued research which has been proliferating in the field of artificial intelligence, machine learning, and analytics. So in 1980s, in fact, the same university came up with WABO 2, and this time WABO 2 was not a general purpose robo like WABO 1. In fact, it was rather a specialist robo, and there is reason why I'm saying so. This particular robo, rather humanoid, was a musician humanoid robo, which was able to communicate with a person to a certain extent, read a normal musical score with its vision, and play keyboard instruments. And it's certainly, that's the reason why I'm calling it out, that it's not general purpose. Artistic activity such as playing a keyboard instrument, understanding the musical notes, these things require human-like intelligence. Therefore, WABO 2 marks the great advancement in the field of AI, to be specific, in the field of machine learning with human-like intelligence. And this was indeed a major milestone or a breakthrough in the field of AI and ML. With that, let's move on to the 1990s. And with 1990s, I would rather say that, okay, the mid 1990s came ALICE, ALICE, okay? So somebody calls it ALICE, somebody calls it ALICE, and then this is also referred as an ALICE bot, right? This, which is a full form, it comes up with a full form like artificial linguistic internet computer entity. It was a natural language processing chatbot, a program that engages in conversation, the program which can really behave like a conversational AI, intelligence sort of stuff. And it was powered by the heuristic pattern matching rules technique. This, to me, is a major milestone in the field of NLP NLU, which is a specific interdisciplinary subdomain of AI and ML. So as I said at the start itself, that when you talk about the subdomain of AI ML is just not computer vision, it's just not predictive machine learning. There are very many more things like NLP, NLU, NLG, like audio and voice analytics, then like knowledge graph. So all these things really make up the larger play of artificial intelligence. And this LAs marks a major milestone in the field of NLP and NLU. Now, with that, let's move on to the 2000, and you see that okay, how things have rapidly, explode, or rather, I would say that okay, a big bang which has happened in the field of artificial intelligence and machine learning. In fact, what has been done in the decade of 2000 to 2010 has really made AI ubiquitous. What you see today, AI, which is used for data mining, which is used for the medical diagnosis, which is used for the surveillance, which is used for the manufacturing shop floor automation. Whatever you see, when you see the Siri, when you see Apple Series or Amazon Alexas or Google Assistant, or the kind of recommendation engine which tells you what you should be buying next online, what you should be watching next online, the automated face recognition, so on so forth, a lot of things. What is happening now is because of that decade of 2000 to 2010, where that a lot of significant progress which has been made in the field of artificial intelligence, and it was primarily as in the form of deep learning, or you call it as a deep neural networks, right, which has revolutionized the field of AI and ML. So I would label it the decade from 2000 to 2012 as the phase of evolution of deep learning or deep neural networks, right, which had really made AI now ubiquitous, and that's why you and I are talking about it, about the artificial intelligence, the mainstream application, the adoption by the very many different industry. And before I move on to the next topic, here is a interesting tidbit for you all. This whole deep neural network, which I was talking about, which has been the frontier of the artificial intelligence now, is primarily credited to three major personalities, or I would say the AI cult. One personality is Jeff Hinton, the other one is Jan LeCun, and then you have Yoshua Bengio. In fact, Jeff Hinton together with Jan LeCun and Yoshua Bengio triggered the success of deep neural network. They are regarded as godfather of deep neural networks or deep learning. Jan LeCun, who is currently heading the Facebook AI research lab called FAIR, and Jeff Hinton is working for Google. And with this, what is happening there? Okay, in fact, these researchers, these academicians, have really tried to bridge the gap between academia and industry. Now, academia and industry are running hand in hand. They are trying to really kind of coming together with their experience and knowledge to make AI more mainstream. So that's what an interesting tidbit. That was a context setting for the AI, a chronology of AI for you. So now let's move on to the next topic of the R, which is what is AI and ML. So there are very many definitions to it. One can really go with a definition which is written in the Wikipedia, but I would rather say that okay, put it simply put across, the way AI should be defined is like AI should be defined as any task performed by a program or a machine that requires application of human-like intelligence to accomplish the task. A task which emulates human cognition, a task which simulates the human intelligence can be called AI. It's a technical simulation, right? It's a technology which uses complex algorithmic techniques to simulate the way neuron works in the human brain. Neurons are, that are the basic unit of our nervous system. So AI should be defined, or it should be defined as an algorithmic or a statistical approach to approximate conclusion, to do the predictions without direct human input. So if I may repeat it again, so AI or ML is algorithmic and a statistical approach to approximate conclusions, predictions without direct human input. And what it means that without being explicitly programmed, it is primarily done for the pattern finding. It empowers data-driven decisions, and you see that okay, because of such things, it is now getting adopted in the wide industry. So that's like a definition of AI and ML at a high level for you. So with this, I'll move on to the next topic, which is what is the machine learning life cycle, right? So this is something, as I've defined already what is AI and ML. This is more of a life cycle of machine learning. So let's understand what is machine learning, not by any sort of theoretical definition, but to really understand that, okay, what is its life cycle. And as it says, that it enables the computers or the machine to make data driven decisions rather being explicitly programmed for carrying out a certain task. That's what the typical definition of machine learning. But now look at its life cycle. So a quick glimpse of the life cycle of machine learning is it begins with defining the objective, which is more about the due diligence, the requirement gathering, that what exactly you want to be doing it, what you want to be performing through the field of your through using the technology AI and ML, that you define it. Then the most, I would say, significant step is data gathering, as there is no knowledge without data, as the junk data would really lead to the junk conclusions or junk predictions. So data gathering is something which is pretty important. You collect data from very many different sources. That's the next step. You bring it together, try to build one single version of truth, okay, of the data. You prepare the data, and that's what, like, bringing the data together, mashing it up, storing it in a place which really kind of then becomes accessible to the data scientists to really start working on and build their algorithm on the top of it, try their hypothesis on the top of it, and try to find out some interesting pattern out of it and all that. So that's about preparing the data. And in typical IT world, we call it as like ETL, or the data flow pipeline sort of stuff. And once the data is collated together, is like one version of the truth data which you really get it, you have prepared the data, then you really kind of get into the data exploration, which is generally called exploratory data analysis, wherein you try to understand the descriptive behavior of the data, you try to understand the abnormality in the data, you try to understand the pattern lying in the data, so all that kind of stuff, the distribution of the data which you understand. And then what you do, that okay, you also try to figure out some of the key features, or I call it as a predictors, or the variables which possibly you would really try to build your hypothesis upon. Once your data exploration is done, you really get into the model building part of it and all that. So model building is nothing but then writing the model script, trying your model algorithm, or writing your hypothesis in a statistical coding language, right? Be it R, be it Python, be it any other language, right? So that's about the building of a model. So once you have, let's say that, okay, in building a model, you may really choose, depending upon the problem statement, go ahead with classification model, maybe random forest, or maybe XGBoost classifier, or maybe you will go ahead with some sort of coordinate based model building for computer vision identification. So on and so forth. You will start writing the code there in the build a model phase, and then you really get on to the model training and evaluation. So once your hypothesis is written in a statistical fashion in the code, then you try to really train that model, you create a binary of the model, and then you evaluate whether the model is doing really good or not with out of the sample data, maybe with the test data, and see that, okay, how accurate it is upon the data which it has not seen while training. So and then you try to identify one or maybe a couple of champion models, and then what you do, then, okay, you put it into the inference pipeline for inferencing, for the continuous prediction, or maybe a batch predictions and all that. So this is a very high level view of machine learning life cycle. And then just keep one thing in the mind, which is also published in the NIPS in year 2015 by Google as well, which calls that the only a fraction of real world machine learning system is composed of ML code. So you can think of it, this building a model, which we consider to be more of writing the algorithm, choosing the model, is just a fraction of it and all that. Just keep in the mind. And then there are very many articles which are there. There is a archive paper which talks about it in great detail, which is hidden technical debt in machine learning system. Okay, so that's about machine learning. Let's move on to the next topic, which is AI ML application. It's quite interesting because that's where you get to see how that AI ML is being adopted by the very many different industry. Again, it is pretty purely illustrative. As and when you and I talk in detail, you will understand that, okay, what are the very many different applications in every particular domain or every particular market sector, right? So one of the sector is healthcare. Whether you talk about the medical imaging AI, whether it is about diabetic retinopathy, or whether you're talking about the brain tumor identification, or whether you're talking about in the field of radiology, doing that skin cancer detection, whether whether by looking at the image itself, or the scan which has been done either through MRI or X-ray or CT scan or PET scan, an AI model can surely go ahead and predict that whether this particular person has really got a melanoma cancer or a benign cancer, right? So there are very many things wherein AI has advanced a lot in the field of healthcare, and in fact, they have advanced so much that there are very many different papers, very many different research, which establishes that okay, in many cases, AI is doing way better than even an average radiologist, and this is something which is there in the Google. You go and search it, you'll find it out that okay, you surprisingly the deep neural network models, primarily the convoluted variants, okay, are doing better than very many different average radiologists. And not only it is doing better, it is also bringing the cost of the whole healthcare. In fact, it is making the healthcare more affordable. So see it, the power of AI, right? So AI application in healthcare is about preventing the disease, about the treating the disease, coming up with the patient outcomes, in very many things. The AI is being used in the healthcare and all that, right? Now, with that, I'll move on to the next field, wherein AI and ML in the finance. In fact, now and during COVID-19, in fintech is really emerging to be one of the major player, which is wholeheartedly adopting AI and ML to make the finance, the credit, the monetary assistance or the monetary credit available to the general public in an easy fashion. You know that okay, during COVID-19 there a lot of mayhem which has happened. A lot of guys have lost their job. A lot of guys are in their financial distress, and fintech is rising to the occasion of helping a lot of those who are in distress, a lot of those who really need the hand holding. Even the government is using AI to really kind of see that okay, how exactly they can do a data driven decision making for the economic policy. So AI in finance, it was already there, and during COVID-19, and I would say that post COVID-19, you would see far more uptick of AI and ML in the financing world as well. So whether I mean, just to really quote some of the very quotidian existence of AI ML in the field of finances, like the fraudulent analytics, credit card fraudulent transactions, or whether you are trying to really kind of go ahead with risk assessment, or whether you are trying to do the financial advisory services, or in the field of trading, right? So everywhere these AI and ML is being adopted to really help improve the top line and the bottom line of the organization, help improve the living standards of the world citizens. So that's like a quick summary of AI ML in the finance. Then we are looking into a very technical, specific subdomain, which is computer vision. Within that, object detection application of AI ML. So AI ML in object detection, right? So whenever you really kind of enroll for AI ML course, or whenever you really get into any sort of introductory video about AI ML, you would see that okay, there would be video, there would be sort of simulation which will be explaining and showing in the live that okay, how exactly using AI ML one can really detect objects. So it's like you can detect object, you can track object, you can bound box object, which is called object detection. So you can see it here. So the objects of interest are being detected, right? Whether it is like a say like a cold drinks, or let's say that okay, in retail world it can be like any vegetable or whatever it is, right? In a general world, like for an object instance detection, like car, bike, TV, flowers, and human, that's what is you see it, you come across. This is what you call object recognition, localization, and detection. And this is something that okay, it's being done very seamlessly using AI and ML, and that's what we are talking about here and all that. There are very many different models which are there and all that. This is I would say a very specific subclass of computer vision, and it comes from the family of RCNN family. So it's nothing but a variant of convolution neural network. It's a variant of reason-based convolution neural network. There are very many different models there. There is something called YOLO. You must have heard about it. There's YOLO V1, V2, V3. Then you have really got, SSD model. Then you have really got mask RCNN. Then you have really got, there are very many different variants which are there. There are Detectron, which has come from from Facebook, which is doing far efficient in kind of not only doing the object detection but also the segmentation at the same time. So object detection and move to the next step, wherein it's just not identifying the object or localizing the object or tracking the object. It is precisely segmenting the object of interest as well. And that's where this field of RCNN comes into the picture. Mask RCNN, the Detectron 2, and all these are part of that particular family and all that. So this is again one of the most widely cutting across application of object detection in the industry. With that, I'll move on to the next, which is predictive analysis. This is something that as I said it, that one of the classical application of artificial intelligence and machine learning is a predictive ML. I call it as more like a predictive or classical machine learning. So predictive analysis, that why do we do it? In fact, we do it to really kind of do the data-driven decision. You to really kind of do all sort of on the structured data, you pick up all the various data points and then try to see that how exactly the trend is happening, what exactly is the future of this particular data behavior in terms of, let's say, what will be the sale tomorrow, or what will be the sale in the coming days, or what are the risk possibility in the coming days. So predictive machine learning, which you generally do it, like say in the field of Python with sklearn library, scikit-learn library, or maybe with Spark ML and all, so on and so forth, is more about dealing with the structured data and trying to really kind of go ahead and do some sort of prediction about that, what is going to be happening with probability in the coming days, right? And then that's where you have really again got the subclasses in supervised, in semi-supervised, and then in unsupervised kind of field and all that, right? With this, let's move on to AI and ML in the marketing and advertisement. In fact, this is something that it is being widely used in the field of marketing and advertisement. In fact, AdWords, I call it as like market and advert field, had extensively leveraged AI, and you see that increasingly there are newer technology fronts of AI and ML which are being adopted by this advert field, be it about sales forecasting, be it about ad targeting, be it about customer behavior analytics, or be it about click analytics, figuring it out, AdWords and all that. These all things are in fact being driven by the AI and ML, right? And that's what you see are the key pillars of marketing and advertisement. How do I really go ahead and make a targeted marketing, right? The world has now come to the stage wherein everybody wants a very tailored, personalized offering, right? Any campaigning which should reach to me should be very tailored, very specific, very contextualized to me. And that contextualization, that degree of personalization, that degree of targeting marketing is being brought by AI and ML in the field of marketing and advertisement. So that's what one of the example here. And then let's move on to the one very interesting aspect, which is AI and ML future scope. However, a disclaimer before we begin, that some of those things which we're going to be talking about are no more like future, they are now mainstream, but we are still quoting it because there are deeper advancements which are happening in those fields and all that. Let's have a quick look into this particular thing, right? So future of healthcare. So this is more about radiology, and as I said you that these things are already mainstream. I've told you that the AI ML has really got the degree of maturity wherein they are able to beat average radiologists. They are able to bring the cost down. They are making healthcare very accessible to the common public. That's what something which is already happening, right? So there's nothing about the future in it, but still we have included it here because there's a lot of research which is happening in the field of healthcare and like robotic surgery. So a robotic arm which is trying to do the surgery of increasingly newer and more diseases which are kind of very stereotyped, are that area that encompassing is growing. So more and more diseases, more and more such kind of surgeries are being done by robotic arm itself, those are being powered by the AI. A lot of research are being pumped into this particular field by the industry, by the academia. So that's why we still call it the future of AI/ML, because here there's a lot of new works which are going on, and then a lot of new funding are being pumped into it and all that. Now with this, let's move on in the interest of time to the next, which is future of self-driving cars. You guys have been hearing the buzzword about the future of driving cars, the autonomous car. You heard about Elon Musk, you heard about Waymo, you heard about so many. You heard about how Toyota is trying to do it and all that. And obviously, this is something which has been there. But why do we say it's future? Why? Because this particular field of the autonomous car driving is certainly a future, as there is a lot of investments still being pumped in, a lot of new researches are being done and all that, because this is a true and extreme, I would say, a fusion of very many different fields of subdomains of AI/ML and engineering. In fact, for an autonomous car, there are lidar camera on the top of it. It is all IoT coming together. So it's IoT, it's AI, it's blockchain, it's the very many different substream of AI/ML, like say computer vision, right? All of these things, reinforcement learning, all of these things come into the picture to really make this work in a seamless fashion. So an autonomous car is something which is a pretty complex deal. It has, you think about it, such a heavy mechanical equipment has to run on its own in a dense populated or otherwise a fast running lane, and it has to take care of a lot of things, right? When you drive, you think about it, that you get completely mentally occupied. All your senses get occupied in this, and when you say all your senses, whether you try to predict, you try to gaze, you try to guess, you try to really kind of see, you use all your senses to really kind of, while you are driving the car, right? So that means it's a fusion of a lot of different AI/ML subdomain, a lot of fusion of a lot of different engineering, like IoT and other stuff, which comes into the picture to make that self-driving car a reality. And that's why I still say it's a future of driving car. Yes, there are a lot of buzzwords which are still there, and still a lot more needs to be done to make it a reality. And the good thing is, like, all these technologies are coming together to make it a reality. So that's why it is future here. With this, let's move on to the other topic, which is robos in manufacturing. Again, this, you have seen it. You have seen it many a times. A lot of those videos which shows that, okay, how exactly that car manufacturing pipeline or the assembly pipeline is using robotic arms to do it in a pretty seamless fashion, identifying the anomaly object there, removing the bad quality object, fitting in the right, doing this whole assembly. So in manufacturing world, be it you are into the hull business, be it in your any kind of large manufacturing, or let's say the, okay, steel manufacturing or automobile manufacturing, AI and ML is being used. So the computer vision is something that, okay, you get to see extensively being used. Then robotic arms are being used, which are powered by the AI, the smart robotic arms. So the manufacturing assembly line, the robots in manufacturing pipeline of advanced players in this field are something which is pretty common, right? But still, their efficiency is being continually pruned. I mean, it's being continually tuned further, right? There are newer frontiers of models which are being developed, the newer frontiers of technology, or I call it as like fusions of multiple subdomains of AI and ML are being done to really make this far more efficient and then far more capable. And that's why we still choose to really opt it here as the future of ML in the field of manufacturing itself. With that, let's move on to the other one, which is future of finance. In fact, we have talked about it, so I'll not spend much time. And I believe that, okay, by now you have really got the sense that, okay, why do we still choose to really keep these all as a future, right? And I'll move on to the next, which is the future of computer vision. Ignore this particular picture, because this is what something you always see as a hello world when you really get introduced to the AI. And this is nothing but an object detection, right? So SSD model or YOLO or any sort of object detection model does the same thing. In fact, if you see it, it is identifying an object, it is identifying a person, it is bonding that. So you can see it, there is a bonding here. And if this person continues to move, it will continue to track it as well, right? So that's what is object detection. then when we call it computer vision, we call it as like a God's eye to the machine. In fact, why do we still think that okay, this is future? Because again, as I said, that okay, there's a lot which is being done to really make it far more improved. As I said, there is something called Detectron 2 or the mask RCNN in a reverse chronological fashion, which not only does the object detection, localization, and tracking, but it also helps it to do the segmentation. So one model which will help you to do both, right? So it will detect it as well as it will segment in the sense that okay, it will only look at my movement of my cursor. It shows that okay, it will only identify those pixels which comprises of that particular object of interest. So you will just not see the full bounding box, but you will see the pixels getting into highlighted in a different color, a light yellow or maybe a light green color. Those pixels only which is only a part of the human body or the person which have been identified there, right? Similarly, there are a lot of things which are again going into it, right? There's auto ML which is coming up in the field of computer vision to really take it to the further extent and all that. So that's about computer vision. Now of the future. Now let's come to the future of NLP. Again, this is, sorry, let me get back. In fact, as convolution neural network, and then I would say that okay, ImageNet, right? The image identification and recognition challenge was the major shot in the arm in the field of computer vision. Similarly, now in NLP, NLU, NLG, there is something called transformers which have really come up. You must have heard, some of you must have really heard about BERT, Elmo, those kind of transformer algorithms. Using that, in fact, NLP has become like far more, the AI NLP has become far more effective, far more efficient. It has got far more contextual understanding of the language which is written there. So when you and I talk, what you do, you really kind of identify the key subjects or the topics which I'm talking about, right? The entities. Then you try to really kind of infer the essence. Then you try to really kind of build your interpretation around it and all that. That's what I would say that is a natural language processing, generation, and understanding. And that needs more of a contextual talking, right? What I'm talking now has got a context and build up to what I was talking earlier, right? All these you have to put it together. You have to, if I'm talking more in the field of AI, I would possibly be using a lot of those terms and technologies which are not the common jargon or common vocabulary, right? They are very, very specific vocab, or I would say that, okay, I'm using a taxonomy. I'm rather using, the words which are very, very specific to that particular field itself. You do get it, because you are into that particular thing. You read it. And that's what the newer generation of NLP world, which is the transformers, are able to do it. It really gets a very good contextual word embedding. It really powers that NLP to that extent that it can really give more like human kind of interpretation, human kind of intelligence or effectiveness in dealing with the natural language. So that's why it is the future. With that, the final thing is the linguistic barriers in conventional AI would really kind of get broken. I mean, obviously there is something called neural machine translation, which can translate one language to another, right? So you can talk in English, and then there are devices which will automatically narrate your message in a Chinese. Let's say that okay, in Hindi, that's like a great thing, right? That's what NLP is trying to do. It's trying to really break the linguistic barrier. So that's why it is future. And then I'll move on to the next topic, which is very, very, very interesting, very upcoming, and very, I would say, like a hot topic, which is immortality, which is, I would call it as like a brain simulation. There are very many platforms which are as of now existing in the world, which talks about which they are or they are for investing. There are very many organizations which are investing in brain simulation platform. I'll talk about it, what exactly it means, right? So what is brain simulation and brain models and simulation? What is the use of it, right? So think about it, that imagine a brain and it's working replicated by on a computer. So let's say that, okay, my brain or your brain is now being completely simulated by a computer. So I don't have to really interact with you to know that, okay, how exactly would you respond next? I'll interact with the machine, which has really got the brain simulation platform running. And then what I'll do that, okay, I'll try to really put some action and see that, okay, how would you respond, right? Now don't get scared about it. I'll talk about the good aspect of it and all that. So this is nothing but then in a typical world, we call it as a digital twin of your brain. You understand the twin, right? Ram Sham ki Jodi, Geeta Sita, and all that twins thing. So here it is a digital twin. So that's what brain simulation platform tries to do it. Why they are trying to do it and all that, primarily in the field of life sciences, in the field of healthcare, this is something that is being used to really kind of bring that immortality. In fact, in a layman word, I would say that that a lot of those life sciences companies or healthcare companies are trying to invest into building such kind of brain simulation platform or a computer environment which can simulate or which can offer to simulate the possibility of studying disease processes electronically, in the sense that the drug researchers do not have to really kind of go through multiple stages of the drug research. There's a phase 1, phase 2, phase 3, phase 4 of typical clinical trials before it really gets comes to the market for everyone to access that. And even if the medicine comes in the market, they're generalized medicine. They are not particularly built for your own human, your own individual human makeup and all that, your own body, right? So they are generic medicines. So with this, what exactly the researchers are trying to do, they look at how to really kind of come up with a personalized medication, how to really accelerate the whole life science clinical trial life cycle in a very quick and faster way, and then do not really make it go through a lot of those trials like animal trials, then the curated trials and so on and so forth, right? And then get to the market fast, right? And then those medications, those medicines, those new drugs will be very, very individualized for a particular person itself and all that. And how? Because there is a brain simulation which has been done, and then how exactly your body reacts to a particular to a medicine can be observed here. So that's what the interesting aspect which is going through. And it's pretty complex. In fact, it's I would say that it's just not AI, it's an interdisciplinary field. I'll tell you why it is interdisciplinary. Because think about it, this is a challenge which is a very complex one. Human brain generally contains around 86 billion brain cells, which we call it as a neurons, and each with an average of 7,000 connections to other neurons, and the connections are called synapse, right? So keep it in the mind, neurons and then synapses. Okay, so this is what we are done with the introductory view of brain simulation platform, call it as an immortality through AI. And let's now move on quickly to the other aspects, which are key skills of AI and ML specialist, right? Now here it is. I mean, it's what you see it on my screen is all what takes you to the specialty level, which takes you to the far more matured level in the field of AI ML. So obviously you begin with maths and statistics to understand it, the whole statistical concept. Then you get into some sort of language, whether it is Python or R. Obviously, the Python is something which is now the de facto language of machine learning experts or machine learning field. Then you really also need to understand the database related languages, which is like, say, the very many different variants of SQLs, ANSI SQL, T SQL, and other stuff to really kind of get the data out of it. Or you can really also do some sort of DMX to really do the data mining extensions on the top of SQL Server kind of database itself. And then there is something called data wrangling and exploration, which is generally called EDA. So you need to really understand the lot of those concepts behind that EDA, which is more like understanding the distribution of the data, doing that feature identification, doing that weight of evidence, and a lot of those things by which you really kind of do the exploratory data analysis, find out the significant features, and then you really move on to the machine learning algorithms. So very many different machine learning algorithms which are there, and then they can be classified under three major branches. Whether you call it as a supervised learning or semi-supervised learning or unsupervised learning or reinforcement learning, right? So like say that in the field of supervised learning, you have really got a classification model, you have really got regression model and algorithms, you have really got a time series model and algorithm, then you have really got, let's say that in unsupervised, you have really got clustering model and algorithm, so on and so forth. You continue to really learn about the machine learning algorithm, and then from here you move on to the deep learning, which is more about the advanced skills in the field of AI and ML. You get to the stage wherein you are now getting to a far more maturity from the technical prowess standpoint in the field of AI ML with the deep learning again. For deep learning, maybe you can really get into the computer vision. The deep learning also empowers the audio and speech analytics. It also empowers NLP, NLU, NLG as well, things and all that. So you can really get into a convoluted kind of model variant. You can get into a sequence to sequence model variant. You can really get into the transformer kind of model variant, and so on and so forth, right? So this really takes you to quite deeper into the AI/ML. NLP is speech processing and computer vision, which is again related to deep learning, and also it has got its own niche. You get, when you start applying these things, you really go even more deeper into it, and these are the things which you should really aim for it. If you're already into the machine learning, go deeper into it and get more of your expertise into it to really to get yourself labeled as a specialist in the field of deep learning and machine learning, right? Beyond that, every, as I say, okay, in every AI ML problem begins with the requirement gathering and begins with the data. Everything eventually ends with some sort of the final inference to be showcased to the common public, to the executives, to the for the operational reporting or whatever. So everything ends with the visualization. If you say that, okay, you are a specialist in the machine learning, you cannot be just limited to a model algorithms. You also need to be knowing about data visualization. These are like end-to-end player. So if you aim to be an end-to-end player, you can look into the data visualization. You also need to have the business communication, the story narration thing. In machine learning field, it's pretty much important to narrate the whole story. The story narration is very, very important skill. How do you really kind of land that whole problem statement? How do you really kind of then communicate the way that AI ML has come into the play, what it has brought in the value? So the story narration is pretty much important in the field of machine learning, and for the seniors, it's very, very important. Problem solving skills, if you're in industry and getting into a very higher level stages and all that, the business communication, problem solving skills, your adaptability, your way, how do you really conceptualize the problem, how do you really kind of ideate that problem, really makes you stand apart. So if you are into, let's say, in a top executive layers and all that, or you are aiming to be into that particular layer, you want to really transcend to that particular level, you should be looking for those story narration. You should be looking at the skills like problem solving skills and all that, right? So these are the skill sets which you require it. Beyond that, if you see it, how to get a job in AI/ML, it's pretty simple. That you go through those things, understand those concepts. I would say that, okay, code your future, go code it. If you are a technical guy, if you're below 10 or 14 or 15 or something like that, you are not into the executives, I would say that, code your future. In the machine learning field, whether you're choosing a predictive machine learning, whether you're choosing a deep learning, whether you're choosing a deep reinforcement learning, whatever it may be, the technology or the technique or maybe the domain, code your future. Go code it, understand that particular stuff and all that. And that's what, here you see the trends. Again, these trends are pretty obvious. You may have seen it, these trends, so many times that, okay, what exactly the kind of mean or average salary offering which you see it in the field of AI/ML. But here is some interesting part that, okay, if you look at the bottom, we have tried to really kind of categorize that, okay, what are the different roles which you see it, like ML engineer, AI engineer, ML scientist, AI researchers and all that, right? So I'll just give a quick note about it. You can, in the mean, you can see on your screen the kind of salary. Again, depending upon very many different surveys, the salary really goes up, comes down, sort of stuff and all that. But AI/ML is ubiquitous now. It's hot, is niche now. You need to be there. It's in fact mainstream as well. So it's niche at the same time mainstream. There are very many companies which are looking for it. You need to be going deeper into it and all that. So I'll not talk about the salary aspect. You can see it. I'll talk about these roles, right? So ML engineers, AI engineers, ML scientists, and AI researchers. So let me begin in a reverse order. AI researchers are those who are doing the high-end research in the field of AI to really make those AI applications far more effective, improve those high-end AI techniques even more advanced, like say AutoML, improve that efficacy. And AutoML in fact runs, like Google AutoML runs using neural architecture search and Bayesian optimization. So they really go deeper into that, try to really kind of dig in, understand that, okay, how exactly these things can be tuned further. Similarly, they go into a more of research-based things and all that, right? And they are not just only the researchers into the modeling part, they are also researchers into the overall pipeline as well. Now, ML scientist is someone who is very, very interested only into that ML area, which is primarily, largely begins with the EDA and then with the model building and model training. That's it. That's where, finding on evaluating. That's it. that's where it ends. So that's what the ML scientist is. Then AI engineer and ML engineer are somebody who are really very expert in ML ops, and they can really take the model which is trained, which have been written, which have been trained to the production. So from lab to the production, there is a whole lot of journeying which you need to cover, right? As I was talking about it early on, that in the field of real world ML system, only a fraction of the system is composed of ML code. There's a whole lot which you need to do. There's 9 yards which you need to walk to really get that particular model from the lab to the productionization, and that's what these guys are pretty good at. They know Docker, they know Kubernetes, they know how to fuse ML ops in the field of AI, ML, and all that, right? There are very many companies which are doing the recruitment even now, and they will continue to look for post COVID-19 era, even during COVID-19, in the current lockdown as well. And when the unlockdown happens, possibly the market would really pick up far more speed in a speedier fashion. That's what very many economists are guessing. They are kind of doing the research upon that, okay, how the market would really recover, what will be the pattern of recovery. So whenever the recovery happens, or even now, if you're good deep into the machine learning, you have options open. You have Capgemini, you have Accenture, you have Dell, you have many more players, Amazon, who are hiring. I mean, they are at Google, they are continuously hiring. You need to be good. You need to code your future. You need to be deeper into it and all that. And there are opportunity. So that's what it is all about. This is what your roadmap should be looking like. Start with the learning program, get enrolled to certification program, which Edureka is hosting it. Edureka has really got a very good tie-up with academia. Let's say they're okay with IIT Guwahati, NIT Warangal. They are doing the tie-up, and then they are giving you the certification course for the PGP on the data science. Go ahead, learn those. Learn the programming language. The course is structured in the way that, okay, they train you the programming language, they train you on the machine learning and AI algorithm, they train you on the advanced concepts of ML and AI concepts. They give you a capstone project wherein you can really go and learn the real-time projects, which is pretty much important. When you do the capstone, you really get to see that what it takes, in fact, in the real world to call yourself like a data scientist, or you call yourself like a ML engineer, right? How exactly the real project really happens. And that will be a simulation through the capstone project. Get yourself certified. As I said, that okay, Edureka had really got a tie-up with IIT Guwahati, NIT Warangal, and then they are bringing, they're soliciting help from industry experts like me, and then trying to really bring that value to you and all that. Once you have the certification, get a job. That's what it is all about, right? So that's it. Thanks a lot.